In question 1, we need to find an ascending powers of x up to x cubed, the binomial expansion of 1 minus 4x to the negative 3. So we know that we always start with 1 plus we get the power down of minus 3 times the term in x, which is negative 4x, plus the power of negative 3, and we deduct 1 from the power, so negative 4 over 2 factorial times minus 4x to the power of 2. Notice the brackets here, it's on all of negative 4x, and the next term will be negative 3 times negative 4 times negative 5, so each time we decrease the power by 1 over 3 factorial times minus 4x to the power of 3. So the power here should always match the factorial term in the denominator, and if I put this on the calculator and simplify, I get an answer of 1 plus 12x plus 96x squared plus 640x cubed plus dot dot dot. In question 2, we're given the expression here and we need to determine the values of the constants a, b, and c. Well, we see that the lowest common multiple of the denominators is exactly the x minus 2 times 2x plus 1 squared. So if I multiply throughout by this, we get that 3x plus 4 is equal to a times 2x plus 1 squared plus b times x minus 2 times 2x plus 1 plus c times x minus 2. Now this identity here holds true for any value for x, so I will be setting suitable values for x in order to eliminate some of the brackets and determine the unknowns a, b, and c. So for me to eliminate the 2x plus 1, I will be setting 2x plus 1 to be 0, which means that x is minus a half, and therefore if I substitute x with minus a half, I get 3 times minus a half plus 4 is equal, well, this part is 0, this part is 0, and I'm left with c times the minus a half minus 2. So we get that 5 over 2 is equal to minus 5 over 2c, and therefore the value of c is negative 1. We can also set x minus 2 to be 0. So if x minus 2 is 0, this means that x is 2. So we are looking at 3 times 2 plus 4 is equal to 8 times 2 times 2 plus 1 close bracket squared, and then these will eliminate, and we are left with 3 times 2 plus 4, which is 10, being equal to 25a, and therefore we get that a is 2 over 5, and we are running out of nice values for x, so I will simply put x is 0. So if we put x is 0, we get that 3 times 0 plus 4 is equal to a times 0 plus 1 squared plus b times 0 minus 2 times 0 plus 1 plus c times 0 minus 2. So this leads to 4 is equal to a minus 2b minus 2c. Well, we know that a is 2 over 5 minus 2b minus 2 times the negative 1, which is the value for c. So we get that 4 is equal to 12 over 5 minus 2b, and therefore we get that 2b is equal to minus 8 over 5, which means that b is equal to minus 4 over 5. So we have just found the values for a, b, and c. We are then told to find the exact value of this integral, giving our answer in the form p ln q plus r, where p, q, and r are rational numbers. So starting with the integral, the first thing is to write this in the decomposed form we obtained in part A. So we're looking at the integral from 7 up to 12 of 2 over 5 over x minus 2 minus 4 over 5 over 2x plus 1 minus 1 over 2x plus 1 squared. Well, the first two expressions here, I know how to integrate them. They're going to give me something with a ln. The third one here, I will write it as 2x plus 1 to the negative 2. So we're looking at the integral from 7 up to 12 of 2 over 5 over x minus 2 minus 4 over 5 over 2x plus 1 minus 2x plus 1 raised to the power of negative 2 with respect to x. So the integral of 1 over x minus 2 will simply be ln of x minus 2. So we're looking at 2 over 5. We've got ln of the absolute value of x minus 2 minus 4 over 5 ln of 2x plus 1, and I need to divide by the derivative of 2x plus 1, which is 2, minus 2x plus 1, and I raise the power from negative 2 to negative 1. I divide by the new power and the derivative of the bracket, and this will be from 7 up to 12. So we're looking at 2 over 5 ln of x minus 2 minus 2 over 5 ln of 2x plus 1 plus 1 over 2 times 2x plus 1, with the limits being 7 and 12. I will substitute the upper limit, leading to 2 over 5 ln. 12 minus 2 is 10, minus 2 over 5 ln. 2 times 12 plus 1 is 25, so it's ln of 25, plus 1 over 2 times 12 plus 1 is 1 over 50, so this is the upper limit substituted. And for the lower limit, I'm substituting 7, so it's going to be 2 over 5. 7 minus 2 is 5, so it's ln of 5, minus 2 over 5 ln of 15, plus 1 over 30, so that's the lower limit substituted. So I will be combining ln together, so 2 over 5 ln 10 minus 2 over 5 ln of 25, I'll do 10 over 25. So it's going to be 2 over 5 ln of 10 over 25 plus 1 over 50 minus 2 over 5, and we're looking at ln of 5 over 15 minus the 1 over 30. So I will combine the two logarithms here together. So we're looking at 2 over 5, and we've got ln of 10 over 25 divided by 5 over 15, and then the 1 over 50 minus the 1 over 30 is minus 1 over 75. If I simplify the expression within the logarithm, I get 2 over 5, and we're looking at the ln of 6 over 5 minus 1 over 75. In question 3, we've got the curve C with this equation here. K is a constant, y is greater than 0, and we need to find dy dx in terms of x and y. We will be using implicit differentiation here, which means we differentiate from left to right, applying all the rules as usual. If we happen to differentiate something involving y, we put the dy dx term. So the derivative of y squared x, I will be applying the product rule of differentiation. So the derivative of y squared is 2y dy dx, and I keep the x. And then I keep the y squared and I differentiate x to give me 1, plus 3 times dy dx is equal to 8x, and the k vanishes because it's a constant. So I've got dy dx on the left hand side as a common factor. We've got 2yx plus 3 is equal to 8x, and the y squared will be moved to the right hand side, so minus y squared, which means we've got dy dx is equal to 8x minus y squared over 2yx plus 3. We are then told that the point P with coordinates p, 2 lies on C, and it's a minimum turning point, and we need to find the value of P and the value of K. So let's start with the expression we had for dy dx. It was 8x minus y squared over 2yx plus 3. We know that P being a turning point means that at P dy dx is equal to 0. So I will be substituting x with P, so 8 times P minus 2 squared over 2 times P plus 3 is equal to 0. Now for this expression to be 0, it means that the numerator should be 0. So we're looking at 8p minus 4 is 0. So 8p is 4, which means that p is equal to a half. Now to proceed and find the value of k, let's recall the expression describing the curve. I will be substituting x is a half and y is 2, which are the coordinates of point P, leading to 2 squared times a half plus 3 times 2 is equal to 4 times a half squared plus k. This gives me 8 is equal to 1 plus k, and therefore k is equal to 7. In question 4, we've got the cone shown here, the fixed height of 5, the radius of r, the slant height of L. We need to find an expression for L in terms of r. Well, we can see the right angle triangle formed here. So we're looking at L squared is equal to 5 squared plus r squared. And therefore, L is the square root of 25 plus r squared. This is the expression for L in terms of r. We are then told that the base radius is increasing at a constant rate of 3 centimeters per minute, and we need to find the rate at which the total surface area is changing when the radius is 1.5 centimeters. We are given the formula here for the total surface area of the cone. It's the base area plus the curved surface area. So starting with this expression, the first thing to do is replace L with the expression we obtained from part A. So plus pi r times r squared plus 25 to the power of a half. I will then proceed in finding ds dr, which is going to be 2 pi r, and then I apply the product rule. It's pi times r squared plus 25 to the power of a half plus pi r times a half times r squared plus 25 to the minus a half times 2r, which is the derivative of the bracket. Well, this can be written as 2 pi r plus pi times the square root of r squared plus 25, and then we've got pi r squared over the square root of r squared plus 25. This is the expression for ds dr. So I can proceed in evaluating this when r is 1.5. So ds dr when r is 1.5, it's going to be 2 pi times 1.5 plus pi times 1.5 squared plus 25 square rooted plus pi times 1.5 squared over the 1.5 squared plus 25 square rooted. And then we proceed in evaluating this. We get an answer of 27.17846 ... We are also told that the base radius is increasing at a constant rate of 3 centimeters per minute. So we've got that dr dt, this is the rate of change of the radius, is equal to 3 centimeters per minute. So I will be combining these two rates of change using the chain rule. ds dt is simply ds dr times dr dt. So we know that ds dr is equal to 27.17846 ... and dr dt has been given to be 3. So if I multiply these together, I get 81.5, and the units are square centimeter per minute. In 5a, we need to find the integral of x squared cos 2x, and we will approach this with integration by parts. So I'm setting u to be x squared, and my v dash will be cos of 2x. So u dash is 2x, and v is the integral of cos 2x, which is 1 over 2 times sine of 2x. This means that the integral of x squared cos 2x dx is the uv, so it's x squared over 2 times sine 2x minus the integral of u dash v, so 2x times a half sine 2x dx. So we're looking at x squared over 2 times sine of 2x minus the integral of x sine 2x. So it's a good sign that we've got a simpler integral to deal with here, because it's x times sine 2x, whereas originally we had a quadratic times cos 2x. But I still need to apply the integration by parts on x sine 2x. So this time I will be setting u to be my x and v dash to be the sine of 2x. The intention is for u dash to give me a constant and therefore lead to an integral that is available analytically. So u dash is equal to 1, and v, it's going to be minus a half cos of 2x, and therefore the integral of x sine 2x dx will be minus x over 2 cos of 2x, the uv, minus the integral of u dash v. I can see that the negative sign here will make this negative positive, so it's going to be plus a half cos of 2x dx. So I can proceed this to get minus x over 2 cos of 2x plus 1 over 4 sine of 2x, because the integral of the cosine is sine, and I also divide by the derivative of 2x, which is 2, so I get the 1 over 4 here. So I can now put everything together. So the integral of x squared cos of 2x dx is equal to x squared over 2 times sine of 2x minus the integral of this one here, which we just found here to be minus x over 2, so minus x over 2 cos of 2x plus a quarter sine of 2x, and the arbitrary constant of integration can appear here as plus c, which simplifies to x squared over 2 times sine of 2x plus x over 2 times cos of 2x minus 1 over 4 sine of 2x plus c. We are then told to hence solve the differential equation given here, giving our answer in the form y to the n is f of t, where n is an integer to be determined. So looking at the differential equation given, we've got dy dt is t squared cos squared t over y squared. So I will be using cross multiplication to separate the variables and collect the y's with dy on the left hand side and the t's with dt on the right hand side. So we're looking at y squared dy is t squared cos squared t dt, and I can integrate both sides. Well, obviously on the left hand side we're dealing with y cubed over 3, whereas on the right hand side I will be referring to the double angle formula for cos. So we've got that cos of 2t is 2 cos squared t minus 1, which leads to 1 plus cos of 2t over 2 is equal to cos squared t. So on the right hand side we're dealing with the integral of t squared times 1 plus cos of 2t, and all of it divided by 2 dt. So this can be further written as a half. So I take the half out, t squared plus t squared cos of 2t dt. And at this point we should be able to recognize the t squared cos 2t to be the integral we evaluated in part A. So we're looking at y cubed over 3 being equal to a half, and the integral of t squared is t cubed over 3. The integral of t squared cos 2t, it's going to be t squared sine of 2t over 2 plus t cos 2t over 2 minus the sine of 2t over 4, and there is a plus c as well. So remember, we are trying to get it in the form y to some power is f of t. So I will cross multiply by 3 to get y cubed is equal to 3 over 2, and we've got t cubed over 3 plus t squared sine 2t over 2 plus t cos 2t over 2 minus sine 2t over 4. Now the constant of integration, the plus c, is also multiplied by 3, but it's still just another constant. So I'm just going to leave it here as plus c, and that's going to be my final answer. In question 6, we're dealing with vectors. We've got two lines here, L1 and L2. We've got their vector equations. We are told that the two lines intersect, and we need to determine the value of P. Now, if the two lines intersect, there must be a value for lambda and a value for mu that will yield exactly the same position vector. So if I look at the I components of L1, the 3 plus the 2 lambda, I will equate this with 8 plus 4 mu, and this will lead to a total of 3 equations. So let's see, 3 plus 2 lambda is the I component of L1, P minus 5 lambda is the J component, and 7 plus 4 lambda is the K component, and this is equal to 8 plus 4 mu minus 2 plus mu and 5 plus 2 mu. So this leads to 3 equations. We've got 3 plus 2 lambda is equal to 8 plus 4 mu, and we also have the 7 plus 4 lambda being equal to 5 plus 2 mu. I have left out the middle equation because it involves p as well. So we've got 7 plus 4 lambda is equal to 5 plus 2 mu. The intention is to find lambda and mu out of these two equations and then go back into the third equation here to determine the value of p. So from 3 plus 2 lambda is 8 plus 4 mu. We get that 2 lambda is equal to 5 plus 4 mu. And from the 7 plus 4 lambda is 5 plus 2 mu. We get that 2 plus 4 lambda is equal to 2 mu. And if I divide throughout by 2, I get 1 plus 2 lambda is equal to mu, which means I can substitute 2 lambda is equal to 5 plus 4 times 1 plus 2 lambda. I will expand to get 2 lambda is 5 plus 4 plus 8 lambda, which leads to minus 9 is equal to 6 lambda, and therefore lambda is minus 3 over 2, which means that mu is 1 plus 2 times the minus 3 over 2, which gives an answer of negative 2. Now that I have found the values for lambda and mu, I can look at the middle equation here. P minus 5 lambda is equal to minus 2 plus mu, which means that p minus 5 times the negative 3 over 2 we obtain is minus 2 plus negative 2. This leads to p plus 15 over 2 is equal to negative 4, and therefore p is minus 23 over 2. In part B, we're asked to find the position vector of the point of intersection, which means I can take either the value of lambda we obtained or mu and substitute into the corresponding equation to determine the position vector of the common point of the two lines. So I'm just going to take mu is negative 2, it's just a nicer number, it's an integer. So if mu is negative 2, I will be substituting here, which leads to 8 plus 4 times negative 2 minus 2 plus negative 2 and 5 plus 2 times the negative 2, and this when evaluated gives me 0, negative 4, 1, which is the position vector of the point of intersection of the two lines. In part C, we need to find the acute angle between the two lines, giving our answer in degrees to 1 decimal place. So to do that, I will be applying the dot product. So I will be dotting the two direction vectors of the lines because there is an angle between the direction of the two lines, and the direction stems out of the direction vector. So the 2, negative 5, 4 will be dotted with the 4, 1, 2, and we know that this is equal to the magnitude of 2, negative 5, 4 times the magnitude of 4, 1, 2 times the cosine of the angle between the two lines. So when I do the dot product, I multiply the I with the I, the J with the J, and the K with the K, and I add them up. So 2 times 4 is 8, minus 5 times 1 is minus 5, and 4 times 2 is 8. Now the magnitude of 2, negative 5, 4 simply means I will be squaring each entry and then taking the square root. It's simply Pythagoras in 3 dimensions. So 2 squared plus 5 squared plus 4 squared times 4 squared plus 1 squared plus 2 squared times the cosine of theta, which is the angle we're trying to find. This leads to 11 is equal to 3 root 5 root 21 cos theta, and therefore 11 over 3 root 5 root 21 is equal to cos theta. If I do shift cos of that, I get that theta is 69.0 degrees to 1 decimal place. We are then told that the point A lies on L1 with parameter lambda is 2, the point B lies on L2 and AB is perpendicular to L2, and we need to determine the coordinates of B. So let's start with lambda being equal to 2 to determine the position vector of A, so that's the vector OA. So that's going to be 3 minus 23 over 2, which is the value of P we obtained earlier on, 7 plus 2 times the 2, negative 5, 4. This gives an answer of 7 minus 43 over 2, 15. This is the position vector of point A. Now the point B lies on L2, and for this reason there must be a value for mu that will give me the position vector of B. So OB can be written in the form of 8 plus 4 mu minus 2 plus mu and then 5 plus 2 mu. We know that the AB is perpendicular to L2, and whenever we've got two vectors being perpendicular, it means that the corresponding dot product is 0. So let's start by finding the vector AB, which is simply OB minus OA. So in our case, it's going to be 8 plus 4 mu, minus 2 plus mu, 5 plus 2 mu, minus the OA, which we found to be 7, minus 43 over 2, 15. So this leads to 1 plus 4 mu, 39 over 2 plus mu, and 2 mu minus 10. So if the AB is perpendicular to L2, it means that if I dot the AB with the direction vector of L2, the result should be 0. So we've got 1 plus 4 mu, 39 over 2 plus mu, and 2 mu minus 10, dot the 4, 1, 2, which is the direction vector of line L2, to be 0. So 4 times 1 plus 4 mu, plus 1 times 39 over 2 plus mu, plus 2 times 2 mu minus 10 is equal to 0. I will expand this to get 4 plus 16 mu plus 39 over 2 plus mu plus 4 mu minus 20 is equal to 0, which leads to 21 mu plus 7 over 2 is equal to 0. So we're looking at 21 mu is minus 7 over 2. And if I divide both sides by 21, this leads to mu being minus 1 over 6. So I will simply take the value of mu of negative 1 over 6, and I will substitute into the expression for OB to get the position vector of point B. So we are looking at OB being equal to 8 plus 4 times the minus 1 over 6, minus 2 plus the minus 1 over 6, and 5 plus 2 times the minus 1 over 6. All of this simplifies to 22 over 3, minus 13 over 6, and 14 over 3. And since we are told for the coordinates of B, we need to write this in coordinate form. This is the position vector of point B. So my final answer should be that B has coordinates 22 over 3, minus 13 over 6, and 14 over 3 for the coordinates of B. In question 7, we are asked to use the substitution u is 4x plus 2 sine 2x to evaluate the given integral. Well, we know that in integration by substitution, we're essentially translating everything, including the dx, the expression to be integrated, as well as the limit. So we've got u is 4x plus 2 sine 2x. So we're looking at du is 4 plus 4 cos 2x dx. So this is the expression for du. Now I will factor out the 4 to get du is equal to 4 brackets 1 plus cos of 2x dx. And if we recall the double angle for cosine, we've got that cos of 2x is 2 cos squared x minus 1. So 1 plus cos of 2x is equal to 2 cos squared x. And therefore I can go back to the expression for du here and write that du is equal to 4 times 2 cos squared x dx. So we're looking at du is 8 cos squared x dx, which is really good news for me because cos squared x is here. So if I divide both sides by 8, I get 1 over 8 du is equal to cos squared x dx. And this means that the cos squared x dx here may be substituted with 1 over 8 du. Let's proceed in substituting the limits as well. So when x is 0, we get that u is 4 times 0 plus 2 sine 2 times 0, which gives an answer of 0. And when x is pi over 2, u is 4 times pi over 2 plus 2 sine 2 pi over 2. This gives an answer of 2 pi, so these are the new limits of our integration. And therefore the integral of e to the 4x plus 2 sine 2x cos squared x dx can be written as the integral from 0 up to 2 pi in the place of e to the 4x plus 2 sine 2x, I will simply put e to the u, and the cos squared x dx will be substituted with 1 over 8 du. This simply gives me e to the u over 8 from 0 up to 2 pi. So I will substitute the upper limit, giving me e to the 2 pi over 8. If I substitute the lower limit of 0, e to the 0 is simply 1, so it's minus 1 over 8. So this leads to 1 over 8 being a common factor, and within the bracket we've got e to the 2 pi minus 1 as required. We are then told that the region R, shown shaded here, is bounded above by the curve. It's bounded by the x-axis and the y-axis, and it's rotated through 2 pi radians about the x-axis to form a solid, and we need to determine the volume of the solid form, giving our answer in simplest form. Well, we know that the volume of revolution is given by the integral of pi y squared dx. So in our case, we're looking at the integral of 6e to the 2x plus sine 2x cos x all squared. The limits are 0 and pi over 2, and I've got the constant of pi there as well. So 6 squared here will give me 36, which can come out. So it's 36 pi, and the integral of 0 to pi over 2 of e to the 4x plus 2 sine 2x times cos squared x. So when I'm squaring this expression, the indices of the exponential term get doubled. So this is exactly what we had to integrate in part A. So we're looking at 36 pi times 1 over 8 times e to the 2 pi minus 1. Obviously the 36 with the 8 simplify, leaving me with a 9 and a 2 here. So all in all, I'm left with 9 pi over 2 times e to the 2 pi minus 1. In question 8, we need to use proof by contradiction to prove that the curve with equation y is 2x plus x cubed plus cos x has no stationary points. Well, in proof by contradiction, we always start with the negation of the statement we're trying to prove, so the opposite of what we're trying to prove. So we say suppose not, which means that the curve with equation y is 2x plus x cubed plus cos x has at least one stationary point. And since we are talking about stationary points, it makes sense to find an expression for dy dx, which is going to be 2 plus 3x squared minus sine x. And at stationary points, we know that dy dx is equal to 0, and therefore we are looking at 2 plus 3x squared being equal to sine x. Now looking at the left-hand side of the equation, we've got 2 plus 3x squared, and we know that x squared is greater than or equal to 0 for all x in the reals, and therefore the left-hand side is always greater than or equal to 2, while the right-hand side, being sine x, is bounded between minus 1 and 1, so the two sides can never be equal. This is a contradiction, and therefore we need to conclude that the curve with the given equation has no stationary points. In question 9, we've got the curve C defined parametrically here, and we need to find dy dx in terms of t. So I will start with dx dt, so I will get expressions for dx dt and dy dt. So dx dt, the derivative of sec t is sec t tan t, whereas for dy dt, if I differentiate the tan, I get sec squared, so we're looking at root 3 sec squared of t plus pi over 3. Now we know that dy dx is equal to dy dt over dx dt, so we are looking at root 3 sec squared of t plus pi over 3 divided by the dx dt, which was sec t tan t, and this is the expression for dy dx. In part B, we need to find an equation for the tangent to c at the point where t is pi over 3, and we need to give our answer in the form y equals mx plus c. So I will start by finding the x and y coordinates. So when t is equal to pi over 3, then x is simply sec of pi over 3, which is equal to 2, while y is root of 3 tan of pi over 3 plus pi over 3, which gives an answer of negative 3. I will also be evaluating dy dx to get the gradient of the tangent when t is equal to pi over 3. This gives me root 3 sec squared of pi over 3 plus pi over 3 divided by sec of pi over 3 tan of pi over 3. Remember, we are in radian mode. This gives an answer of 2. And knowing that the equation of the tangent is given by y minus y1 is mx minus x1, we are looking at y minus negative 3 is equal to 2 brackets x minus 2. So y plus 3 is equal to 2x minus 4, leading to y is equal to 2x minus 7. Now in part C, we need to show that all points on C satisfy the given Cartesian equation where A and B are constants to be found. So in other words, I need to combine together the two parametric equations for x and y in terms of t to get one equation connecting x and y. Well, let's recall that x is equal to sec t, which simply means that x is 1 over cos t. And therefore, if I reciprocate both sides, I get 1 over x is equal to cos t. This means I can draw a right angle triangle as shown here. The angle t is here at the base. The cosine of t is 1 over x. And if I use Pythagoras theorem, the opposite here will be the root of x squared minus 1. And therefore, we can see that tan of t is simply the opposite over the adjacent, which is x squared minus 1 and all square root. So I can proceed. We know that y is equal to root 3 tan of t plus pi over 3. And I will be using the addition formula for tan a plus b. So we've got that y is root 3, and I've got tan of t plus tan of pi over 3 over 1 minus tan of t tan of pi over 3. So we've got an expression for tan t in terms of x, and we know tan of pi over 3 is root 3. So this leads to y being equal to root 3 x squared minus 1 square rooted plus root 3 over 1 minus root 3 times root of x squared minus 1. I need to work on this to match the expression shown in the answer here. So we're looking at y is the square root of 3x squared minus 3 plus 3 over 1 minus the square root of 3x squared minus 3. And what I will do, I will multiply top and bottom by 1 plus the square root of 3x squared minus 3. So I'm trying to rationalize the denominator here. So if I expand the numerators, I get y is the root of 3x squared minus 3 plus the 3x squared minus 3 found by multiplying the root of 3x squared minus 3 times the root of 3x squared minus 3. Then I've got 3 times 1, which is 3. And then I've got 3 times the root of 3x squared minus 3. So that's the numerator. And in the denominator, we've got 1 times 1 is 1. And then we've got minus the root of 3x squared minus 3 times the root of 3x squared minus 3. So it's going to be minus brackets 3x squared minus 3. So let's proceed in simplifying things. We've got y is going to be 4 times the 3x squared minus 3 square rooted. The minus 3 with the plus 3 will cancel out, and I've got plus 3x squared. And in the denominator, we're looking at 1 minus 3x squared plus 3. So all in all, we get that y is equal to 3x squared plus 4 times the 3x squared minus 3 square rooted over 4 minus 3x squared.